Assalamu alaikum. Hello viewers. Today we'll be discussing about one of the most used engineering application in structural design or air conditioning design or even building designs, as these are used to supply one of the most important fluids, most commonly used fluids around any kind of buildings or any kind of structures. So we'll be discussing about is how to design tubings and ducting systems. Tubings are usually used to supply water systems or maybe just sanitation systems, whatever you need, and ductings are mostly used for central air conditioning systems, and they are used mostly in areas where you need central air conditionings and you may afford the costs and the usability and the space required for that. So it's gonna be a very simple feature, and we'll be using sort feature today. Even though this is a very simple thing, but it's gonna be a really useful thing as well. So for that, let's just, for the time being, at the initial stage we go for tubings, and we might just want that a 3D tubing system may just need it. For that we start a 3D sketch, and we can start any sketch in any direction. So let's say we want a network, an open network, but before that I want you to observe that the cursor that has been activated for the line, it has the corresponding plane is drawing written as subscript near the pencil. So if we draw a line, horizontal line in this direction, and then just move it around, the thing that just turned into YZ plane, and maybe we just want things oriented a little different way in XY. It's in this direction, and it's aligned. Now draw something up to this YZ plane. We go to this, just a rough sketch but no certain areas. Let's say we just have a rough system out here, it's just an arbitrary situation. Now let's make a circle, which would be the best one. Yeah, rectangle enough. Make a sketch on it. Make a circle, little circle. As for the tubings, click OK. Now there might just be a problem in case of these sharp corners, since our cross section is a circular one. Let's say if it takes or not. Sometimes it may disturb you. And let's just say settle. This is the profile that would pass through this line, and this is the path. See, in these cases, these tubing sections haven't been too much problematic, but in some situations you might just face some of the problems. In those cases you will be needing to fill these corners, sharp corners out. You may allow thin feature to make a cylindrical hole, so that's good enough for us. Click OK, and this is our tubing system. Even though this is not something practical, but this is how nearly all the tubing systems are done. Let's say for the time moment we delete all of it. And so we start a sketch on the top plane, make a line, hover the cursor background to make a tangent curve. and that's more of our network. And in sub base bars, the cross section won't be taken if it's a totally closed one. Rather, it would show an error message which would warn you about a self-intersecting geometry. So let's say this is our drawing, and now we just move around, and if this is our tubing path, let's say we want a sketch on the right plane, choose our orientation, let's draw a circle in a similar way and go for the swept base bars. Choose this path, use a thin feature, that's more like tube. Now for the tubings it's similar way, but difference is it's gonna be a rectangular section. Let's say in the top plane we want a sketch. This sketch would be our path of the duct. So since we might just have some partitions around, so we'll be making sections, and as these sections aren't uniform, we'll be making sections up to which the uniform lengths are available or uniform change in lengths are available. So we just exit from the sketch, make a sketch on the right plane, and this would be a rectangular section. I'm not just going for some accurate dimensionings, so it's only the process that's needed to design this. The dimensions would be according to the need of the design. So this is our sketch, cross-section sketch. I'm just gonna make this thing a little longer, good enough for us, and exit from the sketch and go for the swept base bars. The profile cross-section would be this one, and the path would be this line. And we need a thin feature since it's gonna be the duct. Let's increase the thickness a little bit, and you might just make multiple sections of these walls since it's gonna be an insulating wall, and you might just need some insulating materials to choose, and you might just keep these parts hollow as well, and that would cause less amount of conduction or convection as well. So go for this one, and let's say it's gonna be two sections from this point, so we make two sketches. Make a sketch on this plane. You could have gone for the top plane as well. One of the sections would be going long, and the amount that would be, or the cross section would be half of this section. So for that, make another sketch on this one. Go for this inner section, and similarly this is swept bars. The path would be this with the thin feature, and SolidWorks would automatically update the recent data that you have used. So we'll be using the same thickness, and as we have checked the merge results, so there isn't any gaps in these things. The merge results can be shown in this part, and we go for another sketch that would be a little carved out here. Let's say it's gonna be a little long, and then a tangent curvature. Similarly, the cross section on this plane, we make another rectangle out here, the inner part of course, and go for the swept again. They are the same thickness of thin feature there. And now if we want, let's say, some kind of sections that would require some of this part to be going this way and some to be straight, for that we go for another sketch out here. There's gonna be some part going this way, and the other one be going straight. So we just, sorry about that, we need to start another sketch for this line. So we start another sketch on this plane. In this case, this would be going straight, and let's say it's gonna have an opening out here. Sketch on this. We could just convert the entities, and the problem is it's going to take the outer part, so we'll be satisfied with this for the time moment. Go for the swept, take this one as path, activate the thin feature. The thickness added here is outwards, so we just change the direction and it's gonna merge with this one. For this case, we need a hollow path and also a duct. So we'll make a plane. This is going to be parallel to this face and going through this point. Start a sketch on it. At this end point, and similarly we'll go for the swept with the thin feature on. Now there's a problem is that this is crossing this way, so let's just modify the sketch a little bit. There's a problem. We'll delete this feature. Now we modified the sketch a little bit. For the dimensions, let's say we check out the dimensions a little bit. This line is 0.12 meter and this line is 0.1 millimeters. Alright, now just edit this sketch. it's gonna be 0.12. This we need to uncheck the relationships, but there's an easier way. Go to this display delete relations. Let's say this coincident, delete it. Coincident, which one? This one. Let's say this one as well. Now should be more flexible. 0.19, and let's just say we want line, center line, to make this symmetric. Much better. Now let's check out how good is our script. Not yet good enough. So we move this one a little more. Does that work? Yes, that looks pretty better. It's quite aligned. Almost there. Since we haven't got any defined geometry, so we're just modifying it approximately. This is where we are facing some problems. Edit this sketch, make them collinear. Delete one of the relationships. Let's see which one. Let's delete some of the coincident relationships. Even though this is a little clumsy system, but nevertheless you might just face this as well. So we make a vertical line and dimension them the thickness of the wall 0.011. Maybe we'll just fix this one and now dimension them 0.011. Now let's just go for the set. Put this one with the thin feature on. See how our profile looks like. Yeah, much better. Now since these two are mated, we might just need something that would cut through this line. We will be able to use the similar sketch that we had used before to make a hollow path. So we just, for the time being, keep it visible and start another sketch. In this case, we will be cutting through our paths. Choose normal to, and the profile would be this one. Swept cut. There, much better. And if we see the sectional view, we see there is a hollow path that air would flow through. Now another problem is this is creating a little bit of obstruction, so we need to clear out this one as well. For that, we just make a cut away path. So let's start a sketch on this plane. So normal tool, and we make a cut away profile. So let's say this is a little smaller, and just extrude it to cut it. Now we cut the profile up to the region that we can ensure there is no obstruction left. And now if we see it, it's pretty good. See the two-way paths, each having its own passages. So this would be the ways that refrigerant or airs in refrigerating systems would be flowing through. So even though this process is a little clumsy, but this is the simplest way probably, and you might just turn things around to make it other feature using and make things simpler. And this part has been a little clumsy since we didn't know the exact dimensions, and if you have the dimensions you might just make things a little more smoother, and these wouldn't have been appearing since those would be merging together, and you might just have some other bendings or other joints or different cross sections, smaller cross section, larger ones. You will have to consider the venturi effects, and we'll have to control the flow rates and the velocity as well as the pressures. So that would be all for this tutorial. Hope you liked it. Please hit the like button below and don't forget to subscribe. Thanks for watching.